Hello everyone. In this session I will be explaining the transfer function of mechanical translation system. How to determine transfer function of a given mechanical translation system. We need to follow the following steps. First procedure is determine the input and output variable separately. That is the first step. The second step is draw the free body diagram corresponding to the given system. That is the second step. Then you need to apply D'Alembert principle and Newton's laws of motion and write the differential equation. Okay, that's the third step. Then convert the time domain into S domain by using Laplace transform. Then later on you have to separate the variable and then take the ratio of Laplace transform of output to the Laplace transform of input. Then you are able to get the transfer function. So this is the method which you can determine the transfer function of a mechanical translation system. Let us consider a given mechanical system. First and foremost thing, you need to draw free body diagram of M1 and M2 separately. Let us draw free body diagram of M1. I will be drawing in this manner. This is M1. First you need to consider what are the elements which are concerning on M1. K1, then B, then B1 and K. This K1 is a spring constant, then B is a dashpot. Then B1 is also another dashpot, K is another spring, okay, which is having the spring constant of K. Now, is there any external force? Right now there is no external force. Okay, now I need to consider the external force here. What you can do is, because of inertia, there is one force that is generating, that is termed by F1, Fm1. Then because of spring, there will be one force that is actually opposing to the motion of M1, that is denoted by Fk1. Similarly, because of dashpot, there is a friction, there will be a friction, and because of B1, there will be one force that is actually acting opposite to the M1, that will be denoting by the letter Fb1. Likewise, there is another force which is due to Fb. So, B is connected between M1 and M2. So, you need to consider the displacement x1, x respectively while calculating the force. Let it be Fb. I will be marking in this manner. Similarly, let us discuss about the friction element K. That is also in the same direction. While taking the force of that particular friction, you have to consider displacement x1, x respectively. Let it be Fk. Let me know how many forces are there. There are 5 forces as you can list it in the free body diagram. You can mark the displacement also. What is the displacement? Displacement will be x1. Now what you can do is, let us write the equation based on D'Alembert principle. According to D'Alembert principle, you can apply the total force acting on the body, that is equal to 0. Let us write D'Alembert principle. Let us explain the same thing with the help of D'Alembert principle. That means Fm1 plus Fk1 plus Fb1 plus Fb plus Fk plus Fk, only that much, that is equal to 0. Then Fm1 means m1 into d square x1 by dt square plus Fk1, Cfk1, that means k1 into x1 plus what about Fb1? Fb1 means b1 into dx1 by dt plus regarding B, let us look at B. B is connected between M1 and M2. So while taking B, that is B into d by dt of what you can write x1 minus x plus while taking K, Fk, what you can write K into x1 minus x, that is equal to 0. That is equal to 0. That is equal to 0. Now you have to take the Laplace transform. Take Laplace transform on LHS and RHS. Then the above equation can be converted in terms of S domain. M1 into S square into x1 of S plus K1 into x1 of S plus B1 into S into x1 of S plus Bs into x1 of S minus B into S into x of S plus K into x1 of S minus K into x of S, that is equal to 0. what you can do is, you can club the term, similar term you can make together and dissimilar term you can keep aside. So let us take x1 as a common factor. x1 of s into m1 into s square, correct? Plus k1 plus b1s plus bs. It's a small correction. x1 of s into m1 s square plus k1 plus b1 of s plus bs plus k. Okay, bs plus k. You have to add one more term, bs plus k. You can put, then you can close the bracket. This can be deleted. Okay, bs plus k minus x of s into bs plus k, that is equal to 0. I will be rewriting for your betterment. x1 of s into, what you can write, m1 into s square plus k1 plus, if you want you can take s is a common factor, s into b1 plus b plus you can call this one as equation number 1. Okay. Now let us see free body diagram of M2. By looking at the diagram M2, let us figure out what are the forces which are acting on the body M2. M2 will be considering this one as a node. F of t, that is acting externally. Okay, that is the input. Then regarding M2, there will be one inertial force that I will be writing Fm2. Similarly, because of this dashport, because of the friction, there will be one damper system. There is a damper system. Because of that, there will be one force that is denoting by the letter Fb2. Similarly, Fb is available and Fk, you can write Fk also. So there are 5 forces that will be acting on M1. That is right. Now apply Newton's second law. You have to apply Newton's second laws of motion. Then how it will become? Fm2 plus Fb2 plus Fb plus Fk, that is equal to F of t. Now we can write the equations. Fm2. What is the equation for Fm2? M2 into d square x, displacement is equal to x, d square x by dt square plus, regarding Fb2, what we can write, b2 into dx by dt plus, regarding Fb, you have to consider displacement x and x1 respectively, b into d by dt of x minus x1 plus k into x minus x1, that is equal to f of t. That is equal to f of t. Now taking Laplace transform. Taking Laplace on the above equation, it becomes m2 into s square into x of s plus b2 into s into x of s plus bs into x of s minus bs into x1 of s plus k into x of s minus k into x1 of s, that is equal to f of s. Again you need to rewrite. Similar term can be taken into together, common factor. X of s is a common factor here. Then m2 into s square plus b2s plus bs plus k minus, I will be taking x1 of s outside, bs, I will be getting bs plus k, that is equal to f of s. So this is the thing which are concerning for M2. Please call this one as equation number 2. Now let us look at equation number 1. Equation number 1 implies, let us rewrite equation number 1 once again. That means x1 of s into m1 into s square plus b1 plus b into s plus k1 plus k minus x of s into bs plus k, that is equal to 0. Actually, our required output, what is our required output? Our required output is x of s upon f of s. You need to write all the terms in terms of x of s. Then only you are able to get that particular output, x of s divided by f of s. Here x1 of s term is also there. So what you can do? So first you separate the value of x1 of s. So let us separate the value of x1 of s. x1 of s equal to x of s into bs plus k whole divided by m1 into s square plus p1 plus b into s plus k1 plus k. So this is the value of x1 of s. You can call this one as equation number 3. x of s into bs plus k whole divided by m1 s square plus b1 plus b into s plus k1 plus k. So this you can call equation number 3. Now you have to substitute equation 3 into equation 2. So let us rewrite x of s into m2 into s square plus b2 plus b into s plus k minus, instead of x1 of s, what you can do? You can substitute x of s into ps plus k divided by m1 s square plus b1 plus b into s plus k1 plus k into ps plus k, that is equal to f of s. Now we can do the simplification. X of s, we can do the cross multiplication. m2 s square plus b2 plus b into s plus k into m1 s square plus b1 plus b into s plus k1 plus k2 minus bs plus k whole square whole divided by m1 s square plus b1 plus b into s plus k1 plus k2, that is equal to f of s. Now you can take the ratio of x of s to the f of s. Take the ratio between x of s to the f of s, that is equal to transfer function. That is implies m1 into s square plus b1 plus b into s plus k1 plus k2 whole divided by m2 s square plus b2 plus b plus b into s plus k into m1 s square plus b1 plus b into s plus k1 plus k2 minus bs plus k the whole square, So I will be putting the entire transfer function to separate block, x of s by f of s, that is equal to transfer function, that I'll be putting everything in a separate block. M1 S square plus B1 plus B into S plus K1 plus K2 whole divided by M2 S square plus B2 plus B into S plus K into M1 S square plus B1 plus B into S plus K1 plus K2 minus BS plus K. Okay, same thing I have written, just I'll be putting in a separate block. So this is the transfer function for the given physical system. One system has been provided with you. You have been asked to calculate the transfer function of the given system. So what is the transfer function of a given system? It is nothing but it is the Laplace transform of output. What is the Laplace transform of output here? Y2 of S divided by what is the Laplace transform of input? F of S. This has to be calculated. So what is the first step? I need to draw the free body diagram of M1. I have to draw the free body diagram. So let us draw the free body diagram of M1. Force F of t is acting externally. So I will be marking F of t. Because of inertia, there will be one force that is known as Fm1. Then because of this dashboard or friction element, there will be one opposing force that is denoted by Fb. Similarly, because of this spring, there will be one opposing force that is known as Fk. Likewise, there is one more spring that has been connected between M1 and M2. Because of this spring, there will be another force that is denoted by the letter Fk2. So now let us list out what are the forces. First one is F of t, then Fm1, then Fb, then Fk, then Fk2. Alright, so these are the different forces which are acting on this mass M1, this body M1. Let it be a node. These are the forces which are acting on the node. Now you can apply D'Alembert principle. Then we can write the equation in this manner. Fm1 plus Fb plus Fk plus Fk2, that is equal to F of t. Then please write the corresponding equations. Then how the equation comes? Fm1 means m1 into d square y1 by dt square, correct? Then what about Fb? Fb means b into dy1 by dt plus regarding k1 into y1 plus one more is there k2 into, how we can write, y1 minus y2, that is equal to f of t. Now you can take the Laplace transform on LHS and RHS. m1 into s square into y1 of s plus bs into y1 of s plus k1 into y1 of s plus k2 into y1 of s minus k2 into y2 of s, that is equal to f of s. Hope it is clear. Now we can separate the terms. y1 of s into m1 into s square plus bs plus k1 plus k2 minus k2 into y2 of s, that is equal to f of s. Now we can call this one as equation number 1. Please note this one as equation number 1. First equation. I will be denoting this is actually equation 1. First equation. Now let us draw the free body diagram of mass M2. I will be drawing the free body diagram of mass M2. Let me draw the free body diagram of M2. So you have to mark M2. So what are the forces which are acting on M2? Obviously there is no external force, but because of the movement, there will be one inertial force that is known as Fm2. Similarly, because of this spring, there will be one force that is acting on that particular body M2, that is denoted by F2. The displacement is Y2. Now you can directly derive the formula. Is there an external force, applied force? There is no applied force. So let it be 0. So what are the forces which are opposing? That means Fm2 plus Fk2. This can be written with the help of D'Alembert principle and Newton law. Then you can elaborate Fm2, m2 into d square y2 by dt square plus, what about k2? That means k2 into y2 minus y1. y2 minus y1, that is equal to 0. Now take the Laplace transform on both sides to convert time domain into S domain. That means m2 into s square into y2 of s plus k2 into y2 of s minus k2 into y1 of s, that is equal to 0. Now we can separate the terms. y2 of s into m2 into s square plus k2 minus k2 into y1 of s, that is equal to 0. Now what you can do is, you can separate the value of y1 of s. Please separate the value of y1 of s. y1 of s is given by y2 of s into m2 s square plus k2 whole divided by k2. Please call this one as equation number 2. Now what you can do, substitute equation number 2 into equation number 1. You are supposed to substitute equation number 2 in 1. Then let us see what will happen. Then equation 1 implies y2 of s into m2 into s square plus k2 divided by k2 multiplied by m1 into s square plus bs plus k1 plus k2 minus k2 into y2 of s, that is equal to f of s. From this expression I would like to take y2 of s outside. y2 of s will be taking outside. So what are the terms which are inside? You can write m2 into s square plus k2 into m1 s square plus bs plus k1 plus k2 divided by k2 minus k2, that is equal to f of s. So we can do the cross multiplication. y2 of s into m2 s square plus k2 into m1 s square plus bs plus k1 plus k2 minus k2 square whole divided by k2, that is equal to f of s. Now I can go for further simplification. How we can take Laplace transform of output to Laplace transform of input? Very easy. Transfer function is given by Laplace transform of output. y2 of s divided by Laplace transform of input means f of s. That is given by, what is the answer? You can directly write from this relation. We can directly write it. k2 divided by m2 s square plus k2 into m1 s square plus bs plus k1 plus k2 minus k2 square. You can put one square bracket if you want. So this is the final transfer function. I will be writing by using separate ink for your better understanding. This is your final transfer function. Okay, we could model the entire system in terms of a transfer function. Next question is, determine the transfer function of the given system. There is one figure in that you need to calculate the transfer function of the corresponding physical system. We are having mass m. Here what you can do is, there is one node you can observe. Here let it be m2. Okay, first and foremost thing, let us draw the free body diagram of individual bodies. I will be drawing the free body diagram of this one, m2. See, what are the forces which are acting on m2? There is no external forces, to be frank. Now, what are the opposing forces? The first force is actually Fk. There is one, in fact, there is a force acting on this particular point, node M2, and of course, we can say that another force that is actually B2. Then let the displacement be. This is x, so we can put displacement of x1. Okay. Now we can apply D'Alembert principle. Let us apply the D'Alembert principle. Fk plus one more force is actually acting over the Fm2, but Fm2 is equal to 0. Okay. Fk plus Fb2 plus Fm2 equal to 0. Here we are putting Fm2 is equal to 0. So only two forces will be acting. Fk plus Fb2, that is equal to 0. Now what you can do? Fk. Fk means because of spring there will be one force. That I will be writing K into x1. K into x1 plus what about Fb2? So this is applicable for two bodies M2 and M. So what I am going to write is B2 into d by dt of x1 minus x, that is equal to 0. So what you can do, you can take the Laplace transform to convert time domain into S domain. Before that you can elaborate it. X1 plus B2 into d by dt of x1 minus B2 into d by dt of x, that is equal to 0. So take the Laplace transform. K into x1 of s plus b2 s into x1 of s minus b2 s into x of s, that is equal to 0. So what you can do, separate the value of x1. Our expectation, what is our expectation? Our required transfer function. Our required transfer function is given by what is the output? Output is x of s. What is the input? Input will f of s. This is your expectation. As per the question, this is your expectation. So we need to get everything in terms of x of s by f of s. So x1 of s is actually one of the odd term. So what you can do, you take x1 of s outside. X1 of s into k plus b2s minus b2s into x of s, that is equal to 0. So you write the value of x1 of s. What is x1 of s? X1 of s can be written as b2s whole divided by k plus b2s into x of s. So please call this one as equation number 1. You are going to call this one as equation number 1. Now let us consider the free body diagram of mass m. Okay, M2 we already completed. Let us consider the free body diagram of mass m. Please draw the free body diagram of mass m. Here first force which is acting externally, that is given by F of t. Now there will be one inertial force that is given by Fm. Then because of friction there is a damper present over here, Fb1, then Fb2. So let us list out. One is F of t, then Fm, then Fb1, then Fb2. Then you can apply D'Alembert principle. Fm plus Fb1 plus Fb2 is equal to F of t. Now we can write the expression m into d square. What is the displacement? Displacement is x of t. D square x by dt square plus what about b1? Fb1. b1 into dx by dt plus what about b2? b2 into d by dt of x minus x1, that is equal to f of t. That is equal to f of t. Now we can take the Laplace transform on LHS and RHS. Taking Laplace transform on LHS and RHS. So what we can write? M into s square into x of s plus b1s into x of s plus b2 into x of s minus b2 into x1 of s, that is equal to f of s. Now you can easily separate the term from the equation. That means x of s into ms square plus b1s plus b2 minus b2 into x1 of s, that is equal to f of s. Now we already know that we can write x1 of s in terms of b2s by b2s plus k into x of s. We already know that. I will be recalling equation number 1. Let us recall equation 1. I will be writing equation 1 again for your convenience. Once again I will be writing just for your betterment. b2s into x of s divided by k plus b2s. This is actually equation number 1. So let it be equation number 2. Put 1 in 2. You can substitute 1 in 2. Then what is going to happen? X of s into m into s square plus b1s plus b2 into b2 minus b2s into x of s into b2 whole divided by k plus b2s equal to f of s. Then you can take x of s out as a common factor. ms square plus b1s plus b2, can do the cross multiplication, k plus b2s, then minus, what is going to happen? b2 square, here also there is one b2s, that is also available, b2s. Here one term is missing, that is s, b2s. Now it is becoming correct. b2s whole square divided by k plus b2s, okay, that is equal to f of s. That is equal to f of s. Therefore, transfer function is equal to, what is the transfer function? X of s by f of s. From this you can take the ratio of x of s to the f of s, that is given b2s k plus b2s whole divided by m square plus b1s plus b2 into k plus b2s minus b2s whole square, that is equal to transfer function. This is a transfer function of the given system. Today we discussed how to derive a transfer function for a mechanical translation system. I have explained different steps also. Please revise everything once again and you can do so many number of problems. In the next video, I will be adding lot of solved examples. So thanks for watching this video. Please share and don't forget to subscribe.